Okay.
Thanks. So welcome everybody to day 3 of Research Bazaar. Appreciate you coming. Make sure that when you are provided the opportunity to get feedback, please do so. We take that feedback seriously and we use it to find future events like this. So what we're going to do today in room 2 is I'm going to provide an introduction to the R package called Shiny. Shiny is designed for you to make web apps that people can interact with, that displays all the cool things you do in R without having other folks have to learn the R programming language. So what we're going to do is we're going to work through R Studio. And so I'm going to go ahead and I am going to start sharing my screen, and then we will go from there. And I'm going to go ahead and share my screen. Just make a note of the message that Patricia dropped in the chat about the workshop being recorded. So we're going to start our studio. Our studio note is usually an icon that has a R inside of a circle. Older versions of RStudio have R inside of a sphere. I'm going to go ahead and fire this up. And the first thing we're going to do is install some packages. So we're not going to create a project just yet, but we'll get to that in a moment. And so we can do this in the console. I'm going to clear out my console to make it a little easier for folks to see. So we're going to install, first we're going to install the Shiny package. And we do this in the console by typing install.packages and double quotes Shiny. So Shiny is all lowercase. Install.packages, parentheses, double quotes, Shiny. And when it's going to think for a bit. One of the things to note is that you may be seeing different output on your screen. I am working on a Linux machine, so that means I have to download the source code for every R package and compile it. And when I say I have to do it, I mean the computer has to do it. I don't actually have to manually do any of that. But if you're using a Mac PC, there's a good chance that the package has already been compiled, in which case you're going to see a whole lot less to buy on your screen when you install Shiny. But that's fine. Can take a moment to think about what we're going to do today. What we're going to do is we're going to start with a sort of a template Shiny app, and then we'll modify it incrementally to get it we want. That's one of the nice things writing Shiny apps. It actually comes with a template whenever you start a new Shiny project, and that's a useful place to start from that packet. So if you have the Shiny package installed, if it's already finished for you, you can go ahead and install the next package, which is ggplot. And the package name is actually ggplot2. And you're going to use the same syntax as we saw before, but for the ggplot2 package. So if Shiny is already installed, you can install the ggplot2. You don't have to use ggplot2. You're going to create a Shiny app. You can use the base graphics just with Shiny, but we're gonna go for a slightly more appealing plot in our web app. So that's why we're going to use the ggplot2 package. And if you missed it, there was a presentation yesterday on how to use ggplot2. We're going to do a little bit of it, but not get into too much of the nitty-gritty details. I believe the session was recorded, so you should be able to go back and look for that if you missed it. This is one of the joys of working on a non-standard operating system, is that you get to see all of the nitty-gritty details of things as they come through. if you have installed the ggplot2 package as well as the Shiny package, you can head on to the next package, the last package, and that is the Palmer Penguins package. This package has some nice data in it that we're going to use to do some plotting with. I can't count the number of times that I've misspelled Palmer Penguins, so I just copy it from the chat to make it easier.
Okay, do you want to talk about show again? Yeah, but you're okay. I mean, I'm just like listening.
My package in studying, because nothing like having something take long to participate in a workshop. I'm curious to know what other sessions in ResBazAZ folks have attended. So if you want to maybe drop a note in the chat and just let me know what other sessions have you been to so far in ResBazAZ. Assuming we can all use the chat, it's not entirely there. We can use the chat. Very cool. So it looks like folks have been diving into some Python, which is exciting. It's always cool to work in both Python and R. Sometimes that can be challenging because I try to use R syntax in Python. Looks like learning and the Bayesian analysis have also been attended. That's great. That's great. That's one of the cool things about the ResBazAZ is just all the different offerings that are available for folks. And then let's go ahead and follow up that question with what are we looking forward to for the rest of ResBazAZ? Are there other workshops that folks are going to go ahead and head over to either later today or further on in the week? Have folks even looked at the schedule for later on in this week? Good. So some database interactions with R. That's really matured a lot in the past couple of years. Very cool. Yeah, and Heidi does call out Hacky Hour on Thursday afternoon. I would encourage folks to hop into Hacky Hour if you have not been to that. That's a great place where you can actually just meet and interact with some of the folks who are in the greater data science community here at the University of Arizona. It sort of alternates in between a drop-in help session. So like if you got HPC questions or Python questions, folks there who are knowledgeable. If you also just want to bullshit about the cool things that you're doing, it's the place for it. So cool. Yeah, so there's another, and there's good some nice machine learning work with scikit-learn that's going to happen later on this week as well. So that's good. So I'm curious to know, so we had 3 pages. We've got the Shiny package, we've got the ggplot2 page, and there's Palmer Penguins. And yeah, this is always the challenge, is that I'm as the speaker and good old fashioned Zoom is that trying to monitor the chat can interfere with what you see. So I'm going to close the chat, hopefully not miss too much, and the helpers will actually check in with chat. But I'm gonna go ahead and ask a question, open up my chat, and you can ignore the big black box on my screen because there's really nothing exciting except for my my compiler doing its work. So so now in the chat, if you is anybody still so either type in the chat window, either still installing if you're still installing packages, or type done. Install 3 packages. Looks like some folks are done. Again, if you're still installing, that's great. Just drop still installing in the chat. It looks like most folks have finished, which is great. So so what I would say is we can actually go ahead and get started with them. You're gonna at this point, because my R is taking its own sweet time. I'll give you instructions, and we'll go slow, and I think we'll be able to do this just fine. So what we're going to do is we are going to create a new project in RStudio, and the way we do this is we through the menu. So select File and New Project. And although you're not going to see anything up here because RStudio is busy, select New Project. The first dialog is going to ask you basically where do you want to put this project, and you're going to select New Directory. So we're going to create a new folder. Now the next dialog is the project type. Should be the project type. And here you want to select Shiny Web Application. It's probably the third one down on the list. If you don't see Shiny Web Application, you may need to restart RStudio. Usually you don't have to restart RStudio, but if you don't see it as an option, if you don't see Shiny Web Application as an option, you're going to want to go ahead and restart RStudio. So for the project type, you will select Shiny Web Application. And in the final dialog, you're going to have an option to name your project. Let's go ahead and name the project Shiny-Lesson. And then for the directory, as far as where do you want to save this project, I would put it somewhere where you can remember. I usually save them on my desktop for lessons such as this. If you're going to save it and you're working on your own projects, put it maybe in your documents folder. And once you're done with that, you can say OK, and you should have a Shiny Web App, and that should open up to create a new project for the Shiny Web App. And if anybody didn't see any of those options, or things aren't quite showing up the way I described them, drop a note in the chat and we'll see what we can do to troubleshoot that. So the Shiny Web App that you just created, it actually has 2 important parts. So there is the UI. So UI stands for user interface, and that starts about line 13 in the script that opens up, in the Shiny Web App that opens up. Yeah, so there's a good question in the chat. You don't need to create a Git repository when you create the project. You can if you want. For this lesson, you don't need to. I would suggest that for the most part, like if you haven't started using Git for your code, then it's probably a good practice to get into. It will make your life a lot easier. And I think there is a workshop on, well, yep, I'm pretty sure it's concurrent right now. Workshop on GitHub, but that'll be recorded and you can look at it later on. So so the first part of the app is the UI. The user interface starts on line 13. So this handles the communications with the user. That is the person sitting at the computer using the web browser. So it records any choices and information that the user is going to input, and then it will display things displaying the output based on the selections the user made. So if you scroll on down to line 36, that's where you can see the server section. So my Shiny app has finally finished. I'm going to quickly grab that Palmer Penguins package. I've already got ggplot2 installed, so I don't need to do that. Palmer Penguins is a bit smaller, so it should finish a little quicker. There we go. The important part when you're installing packages is you get this message at the end that says done and the name of the package. And that may be slightly different if you're on a Windows or a Mac. So if you missed it before, we're going to do the project creation. Go to File, New Project. First option is New Directory. The project type is a Shiny web app, the third option down. I'm going to call this Shiny Lesson, and I'm going to create the project as subdirectory of the desktop. So that's what we're doing. We're leaving it here as a desktop, on the desktop. I see create project. It's going to spin for a moment, and then it's going to open up the one file it's created. I didn't open the file, and I'm sorry if you didn't see this file, but click on the app.r file that is in the lower right pane. So app.r in my files tab in the lower right pane of your RStudio instance. If I click on that file, it's going to open up the file that I was talking about. I'm going to scroll on down. Line 13 is where the UI starts. And so we see here that UI is a variable of some sorts, and it's going to assign whatever comes out of this fluid page function. Okay, and we're not going to worry too much about that right now. If we scroll on down to line 36, we see the other half of the Shiny app, which is the server object. And here we're actually defining a function. So server ends up being a function that takes two arguments, the input and the output. And then there's actually one more important part of the Shiny app, which is the very, very last line, line 49. And so some folks may see two different files. So some folks may see UI.r in the lower right corner. They may see UI.r and server.r. In some cases, they end up being separated. I don't know exactly why it's split in some cases and why it's not split in some cases. So basically what R has done is split things into two different folders. And I think it should run okay, but I'm not entirely sure. We'll give it a yeah. So there are some versions of Shiny that will create two different files, actually, one file for the UI and one file for the server. We'll see. We'll troubleshoot. They may work fine. They may require us to do a little bit more work, but we'll see how it goes. So this app.r, and I should say that if you have two different files, if you have a UI.r and a server.r, open them both up, and you'll be able to look at them there. The last line in the app.r is actually what runs the app. So this Shiny app function is actually going to launch everything. So whenever we do the Shiny app, it's always good to sort of test drive things. And so let's go ahead and do that now. In app.r, there is a button near the top right of the script that says Run App. So this button, Run the Shiny application. When we do this, it's actually going to launch our application, and it's going to do it in an RStudio window, and we'll see what that looks like. So go ahead and push that button now, Run App, and it's going to do that. It's going to load up the Shiny package, and it will open up a little. This is actually a little browser window. It's the RStudio browser, not your Firefox or Chrome browser. I will say that sometimes when debugging, things don't quite look right in the RStudio browser. And if that's the case, then you can always push the button near the top of the app that says Open in Browser, and that will open in whatever default web browser you're using, be it Chrome or Firefox or Safari. So this is the Shiny app that's built in. What it is it's showing old faithful geyser eruptions. So it shows basically how frequently the eruptions occur, the waiting time between eruptions. And what we can do here is we can change the binning of the histogram. So there's a slider on the top left part of the app, and we can make more bins. And when we do that, we see a response in the plot changes, and we can drop it down to fewer bins, and the plot will also change. So this shows you how the UI, which is what we see, works, where we do something in the top left corner, we change the number of bins. R takes that information, sends it to the the server part of the app, which does some sort of work, some sort of computation. And then that sends it back to the UI and displays the histogram here. So this works, very cool. What we're gonna do is we're gonna close this app, so we can close this down. And now what we're gonna do is we're gonna go ahead and start working on our own app. Whenever I write a Shiny app, I never start from scratch. That is, I always start with this template. And that's because if I started from scratch, I'd break things. I just would. There's no way I would remember what goes where. So what we're gonna do is we're gonna start from this file, and we're gonna modify it to meet our needs. So the first thing we wanna do is right below line 10, we want to load in those other libraries we're gonna use. So after line 10, I'm gonna add a new line and type in library parentheses Palmer. See, I did it. I misspelled Palmer penguins. Okay, we're gonna back it up, and we're gonna now not be smarter than RStudio. And where RStudio suggests that I use Palmer penguins, I'm gonna press enter, and it's gonna finish it up for me. We're also gonna add library parentheses ggplot2. So any code in my app, if there are any third-party packages that I'm going to use, I want to put the calls to library right up here at the top. I don't want to put them, nested somewhere deep down inside some function. I want to put them right up here at the top, so that the first thing that happens when this app launches is that those libraries get loaded in. Okay, so we've got our libraries ready to go. The next thing we're going to do is change our title panel. So on line 18, the title panel says old faithful geyser data. Well, we're not going to be plotting geyser data. We're going to be plotting penguin data. So let's update that. So I'm going to say penguin size relationships, because that's what we're going to plot. So go ahead, change line 18 to reflect what our plot is going to show. So the earlier app that we saw had a slider to choose the number of bins. That's not what we're going to do because this data set includes data from 3 different penguin species. We're going to have the user pick one of the species to visualize. So let's go ahead and now we're going to change line 20, which is a comment. So line 20 starts with sidebar. So line 20 is sidebar with a slider input for the number of bins. So that's not what we're going to do. We're going to change this. We're going to say it's a sidebar with, and then after with, we're going to say text input for penguin species. So we've just updated the comment. We haven't changed any code here. We've updated the comment with what we're going to do, and we'll actually change the code in a moment or two. We're going to go ahead and slide on down to line 30. So right above the main panel, so you're going to see on line, at least in my script on line 31, it says main panel. Right above that, we're going to change that comment. So it says show a plot of the generator distribution. we're going to change that to say, show a size plot for selected species. So again, just updating the comments, haven't touched the code just yet. And then the next thing we need to do is actually do a change in the server code. Again, if you've got two files, you're going to want to open up the UI.r file and make those changes that I've just mentioned. And if you've got a server.r file, that's where you want to go to next. We're going to go ahead and scroll down, and in the server section, if you're working from app.r, this is going to be around line 37. So really just right up above server. If you have a different server file, it's going to be right up near the top. We're going to go ahead and say, it says define server logic required to draw a histogram. We're going to say create size plot for penguin species. Okay, so now we haven't really touched the code, but now we're going to go ahead and do that. So head back to the UI section, and that's within app.r or within UI.r. And you've got a section called sidebar layout, probably starts right around 21. So you've got sidebar layout, and then within sidebar layout, you've got a sidebar panel. And then within sidebar panel, you've got a slider input. So what we want to do is we want to delete the slider input. So we're not going to use that slider anymore. So we want to delete the slider input. Now this is where we want to pay attention to sort of what we're doing here. You want to delete slider input, which is a function, and all the arguments that are passed to slider input. And then one closing parentheses. That's all we want to delete. So I'm going to go ahead and do that. And you should see something that looks like this, which is a call to sidebar panel that has nothing in it. And there's nothing in sidebar panel. So we're going to replace that slider with text input. So TEXT INPUT, making sure that that I is capitalized. And then open a parentheses. And here's where we're going to put the arguments for text input. We start with input ID. And input ID, the second I is capitalized. We say equals, and then in double quotes, species. And I'm going to have it all lowercase. And this is the identifier that the server section of our script is going to use. And we'll see this in practice in a moment. We add a comma. I'm going to add a new line and say label equals, and then double quotes. And I'm going to say species. And this time I'm going to use a capital S because this is what's being displayed to the user. And then a comma, one more line, and then I say value. So we're going to give it a default value. And for the default value, we're going to use Gen 2, the Gen 2 penguin as the default. So what we've just changed is we have changed the user input section of our Shiny app. What we need to do now is we need to actually change the server, that is the real heavy lifting compute stuff that's in the server section, so that it will respond to this text input. So that's one thing to note, is that we have just broken our app, because the server section of the app right now is looking for some number from the slider input, which we've deleted. So let's scroll down to the server section, or open server.r. And what we're going to do is, in this render plot section, we want to delete what is inside render plot. So on line, at least in my script, line 38 is output $dist_plot is assigned the output of the render plot function. We're going to delete everything inside render plot. So we're going to delete the comments, the assignment of X, the assignment of bins, and the call to histogram. So go ahead and do that. Now be sure you leave the opening and closing parentheses and curly braces. So render plot rather is going to have a parentheses immediately followed by a curly brace. And then those are going to be paired at the end by a closing curly brace and a closing parentheses. So you want your output dist plot to look like what you see on my screen now. So now we're actually going to do some ggplot. And basically any plot that we create in this space is going to be displayed in our app. So let's go ahead and type ggplot parentheses. And we say data equals, and we're going to use Palmer penguins. That's not correct. I'm not correct at all. I'm going to delete this. So one of the things that I want to point out here is that when I type in ggplot, it doesn't actually suggest the ggplot function. And the reason it doesn't suggest the ggplot function is I don't actually have ggplot loaded up for use yet. I have it at the top of my script, but I haven't run it. So in order to make my life a little easier, I'm actually going to load these two libraries. I'm going to load Palmer penguins, and I'm going to load ggplot too. Shiny was already loaded up when we ran our app, so I'm good there. But let's go ahead and load Palmer penguins. I'm going to put my cursor on line 11, hold down the command or control button and press enter. And it's going to load up Palmer penguins. Nothing too exciting is going to happen. We're doing the same thing on line 12, hold down control or command, press enter, and ggplot's getting loaded in. So now that we have ggplot loaded up, it's going to make it a little bit easier for RStudio to make those suggestions. So once you have those things loaded, head back down to the server section. And again, we're working in the render plot. So inside render plot, now I'm going to type ggplot, and we can see now, instead of just suggesting the package ggplot2, it's actually suggesting a variety of functions. So we're going to use ggplot. We're going to use that very first one, press enter. We say data equals, and now we want penguins. So there's, when you type in PEN, you should have two things pop up, at least two, penguins and penguins raw. We're going to use penguins, the clean data set. But now I'm actually going to use a square bracket because if you remember, we're only going to display the information for one species at a time. So I'm going to do a subset in the call to ggplot. So I say data equals penguins, a square bracket, and then penguins, $ species equals equals. So we only want to equal one of those species, the species that the user selected. And where is that information stored? The information stored in the input object. So input $, and then I need to provide the ID of the information that we're using. And if folks remember what the ID was that we used in our text input, if we scroll on up, we can actually see it in my screen. So I want it to use the information that is stored in the species input. So I use input $ species. And then after species, I have to add a comma because penguins is a data frame and we are subsetting based on rows. And we want all the columns of data. After that square bracket, but before the closing parentheses, I'm going to add a comma. And I'm going to say mapping equals AES. So this is where we tell ggplot what we want on the X and what we want on the Y. So X equals bill underscore length underscore mm. So this is the length of the bill in millimeters. After that, we'll add a comma and say Y equals bill underscore depth underscore mm. And the last thing I'm going to do after that mm is a comma and say color equals sex. So we're going to color the points differently based on the sex of the individual from which the measurements were taken. Take a moment to make sure that you have spelled and capitalized bill length mm and bill depth mm correctly. R is case sensitive, so you're going to want all of these to be lowercase because the column names in the Penguins data are all lowercase. So make sure you've done that. After those two closing parentheses, we're going to add a plus sign, press enter, because we have to do one more thing, and that is tell ggplot how to actually plot these points. So we're going to do geom underscore point, and then an open and close parentheses. And now we have finished with our update. And at this point, we've actually changed quite a bit in our app. And I don't want to go any further without testing what we've done. We should have at this point a functioning app. So that's cool. It should work. Let's go ahead and do that. So we have our updated app. Go ahead and push the Run App button. Now at this point, if there were maybe if there were typos or something didn't quite get translated correctly, you should see error messages in your, I'm moving my little app off the screen for a moment here. You should see error messages pop up in your console in the lower left pane if there are errors. I'm getting a little warning message saying removed 1 rows containing missing values. So it looks like at least one of the measurements for the Gen 2 Penguins did not have either or both measurement length or bill depth. So at this point, we should have a plot for the Gen 2 Penguins. And if we want to see how the app responds, we're actually going to change the species. So in the upper left corner, I've got the species field, and I'm going to delete Gen 2 and replace it with another species name. So let's try chin strap, all one word. And you can see once I finish typing in chin strap, the plot is updated. So it's taking the information that the user has typed in and responding to it by updating the plot. Let's try that third penguin, which is Adelie or Adele. Don't quite know for sure myself, but it updated the plot once again, showing the points have changed. So now, maybe you've already done the next step. Maybe you've shown what happens when users may have a little bit of a challenge. So let's actually try. So if I delete the species entirely, you can see the plot is blank. Let's go ahead and let's type in another species name. So now I type in what I think is Adelie, and nothing is showing up. So why isn't anything showing up? And the reason nothing is showing up is because I misspelled the penguin name. So there is no Adele penguin, A-D-E-L-E. There is an Adelie penguin, that is A-D-E-L-I-E. If I update that name, it shows up. So this is a really good point that when you're designing a web app is to think about where your user's coming from. If your user types in something like this, Adelie, and just sees a blank screen, well, it's immediately assumed that it's a bug. So that is most users, myself included, will immediately assume that they did not make a mistake, but there is something wrong with the program. So this is the PEBKC bug, which we've all encountered. We have all been that bug. So the question is, how do we deal with this? So how do we deal with the challenge of users maybe not remembering the names of the penguins? And the way to do it is to just change the way we ask for input. I will show you, sorry about that. You don't need to do this yourself. I'm going to close my app so you can see my screen. You don't necessarily need to do this yourself, but if I type in penguins, square bracket, penguins, $ species, equals, and then that misspelling of the Adelaide penguin. So this should print out all of the data that correspond to this species. That's ADELE. And the answer is there are none. So what it spits out, it says it spits out a tibble with 0 rows and 8 columns. So there are no matches. If we do the same thing, penguins, square brace, penguins, $ species, equals, and then double quotes ADELIE, correctly spelling the name of the penguin, it's going to spit out the first 10 rows of data. And so we have to get into the head of your users and think about, what do you expect your users to do, and how can we sort of work around that? And the recommendation in the chat is exactly what we're going to be doing. So great idea. So let's scroll up to our UI section. So head up to the UI section, and online the text lines 20 through 25. We're going to check that in. Okay, so it was a text input. So what I'm going to do is I'm going to take those 3 lines, and whenever I make changes like this, when I know something works, I am reluctant to just immediately delete it. So let's take those 3 lines and we're going to comment them out. You can put a # in front of each line, or you can select all the lines, hold down the Shift key, hold down the Control or Command key, and press C, and that will comment out all of the lines that I have selected. So what we're going to do now is we're going to update the input. So we had a text input, but let us instead use select input parentheses. And we again start with input ID. We're going to use the same input ID. So input ID with the second I capitalized, equal to double quotes species. After the double quote, add a comma. We're going to say label equals, and now we're going to be a little bit more explicit, and our label will actually include instructions. So let's say select species, indicating that the user should select a species. Add a comma and press enter. And then we have to say which choices to provide. So we're going to say choices equals. And so what are the choices? Well, the choices are Gen2, Adelaide, and Chinstrap. And one way we could do this is we could provide a vector with Adelaide, comma, Gen2, double quotes, comma, Chinstrap. So this is one way to do this, is provide a vector of the names of the different penguin species. However, we now have a point where we have diverged from our initial data. So I know this because I looked at the data. But what happens if those data change? So if all of a sudden now we have data for the emperor penguin as well, I would need to go through and change this choices section. So instead of hard coding it, like we've done here, we can make it dynamic and based on the actual data itself. So I'm going to delete what I just typed. My apologies to anyone who was trying to type to catch that up. We're not going to use that. But instead, we're going to use a function called unique, and then parentheses, penguins, $species. So unique is a function in R that will pull out all unique values that are found in whatever you pass to it. So in this case, we're going to pass it just the species column from the penguins data. So we take that whole species column and we pull out only the unique values. That is, we pull out Gentoo, Chinstrap, and Adelie. And those will be the choices, those three things. Now, if we do this and all of a sudden penguins now has data for a fourth species, the emperor penguin, we don't need to change because we're making the choices based on those data. If you want to see the unique function in action, you can actually do that in your console. And that's one of the things that I'd encourage folks to do, is to test out these functions in the console whenever possible. So we can say unique, penguins, $species, still can't spell species, biologist, 20 years. So let's go ahead and run this line. And when we run that, what it does is it spits out the three values, Adelie, Gentoo, and Chinstrap. So what it's going to do is it's going to pass a vector of those three names to the choices argument in our select input. So at this point, we have changed the way we do input, and this is a great spot to do a test of our app. I'm going to go into a, yep. So I should say, at the end of the workshop, I'll go ahead and be able to provide a link to all of the code that we use today. You'll have a link to the entirety of today's lesson. The lesson's also being recorded, so if you missed part of it, you'll be able to go back and watch it. But I'll provide a link both in the workshop and then as well in the HackMD page so that folks can have access to the code that we use today. So let's go ahead and test our app again now with this new input. Make sure that you've got the right amount of parentheses in here. Make sure that your input ID is species all lowercase. Because again, this species, whatever word we put in here, that is going to be used in our server section down here. So it's got to match exactly. So I'm going to run my app. And it's got unsaved changes. This is one of the things that Shinies in RStudio are telling me. It's like, well, you don't have everything saved, so I'm going to cancel. I'm going to go ahead and save my file. I can also tell that there's unsaved changes because in the tab app.r, the text color is red and there's a little asterisk by that file name. When I do Control S or Command S, the text turns black and the asterisk goes away. So now all of the changes have been saved. I can run the app. And now we should see the apps that appears. And note, we no longer have a text box in our upper left panel here, but rather a drop-down menu. And now I don't have the opportunity to misspell the name of a penguin. All we can do is select the options there. And every time I select something different, it's going to update the plot. Okay, at this point, we're going to be adding more to our app, but I want to pause for a minute and ask what questions folks might have at this point about what we've done. Okay, so it looks like there might be an error. Fun. There's a label missing. I'm going to move my app over to the side. So what we want to make sure is that in select input, we need to provide three things. We need to provide an input ID. We need to provide a label So label equals select species, and make sure these are separated by commas. So input ID, species, comma, label equals select species, comma, and then choices. So we want to make sure we have all of those arguments passed to select input. And I would say whenever you're going to go ahead and make changes to your app, you want to go ahead and close that app down. So we can see I've got the penguin size relationships. If I'm going to make a change, I'm going to close it down. The app stopped running, and now I can make any changes that I want. Okay, there sounds like there's still an error, and I'm not quite sure what's causing that error, but we're gonna actually take a break in just a couple of minutes, and we can try to debug that error there. So in our app, we have been looking at the relationships, size relationships between these different measurements for build length and build depth. But perhaps one of the things we want to do is we want to actually do a correlation or a linear regression. So looking at how well does build length predict build depth, and then do some sort of linear regression, and then add that to our app so that some information can be displayed to the user. So what I'm thinking is it'd be great to do linear regression using build length to predict build depth, and then display a little output of the coefficients table down below the plot. So I'm going to close the app. And what we're going to do is we're going to start by putting the sort of the server side processing. That is, what are the computations that are going to need to happen? And then after that, we're going to worry about how that information gets displayed. So scroll on down to the server section. And after output $distplot, we're going to create something else. So let's go ahead and after that final closing parentheses, so there's this whole section that creates the plot. What we're going to do is we're going to create another type of output. Okay, sounds like the error's gotten removed. If you had a similar error, make sure that this text input section gets either commented out or deleted, your choice. You can have multiple inputs, but we can worry about that later on. So back to the server section, we've got this output distplot after this whole render plot section. So render plot stretches from lines 41 down to 47 on my script. So after that last closing parentheses, we're going to make a new thing. So we're going to say output $, and I'm going to call it stats table, and then assign it a value with the assignment operator that's a less than sign and a minus sign, and we're going to use render table. And then I'm going to open up a parentheses, and then I'm going to open up a curly brace and press enter. So the syntax that we see here is very similar to what we saw for render plot. That is, we have an output object, and then a $, and then the name of the thing in output. And in this case, we're calling it stats table. Before, they had distplot. And if we wanted to, we could probably change the name of distplot because we're not plotting the distances between eruptions anymore, for plotting size plots. But for right now, we're going to leave it as is. So I have output stats table. And what we're going to do is going to go ahead and right above that line, add a little comment. We're going to say add results of linear model to output. That's what we're doing. inside the render table call, inside that curly brace, I'm going to go ahead and roadmap out the steps I need to take. So I'm going to put a comment and I'm going to say create the linear model. I'm going to add 2 spaces, add a pound sign, say extract summary statistics, add 2 more empty
I have a
lines.
question in the chat, Jeff.
Oh, thanks, Kelsey.
Why curly brackets between render plot?
Oh, yeah. So good question, Jessica. So, so one of the things that's kind of funky about this Shiny syntax is that we've got render table, and then we've got a parentheses right after, which is sort of normal. We're used to this because render table is a function. So we open up a parentheses, and then you see this set of curly braces. And so this seems sort of redundant. Like, why do we have a parentheses and then a curly brace? And so the answer is, I have no idea. This is the way you do it in Shiny. There are reasons for it, and I imagine the hive mind will educate us. And this is why I start with the templates for the Shiny apps, is because this is the way they do it, and so I continue to do it this way. I would be keen to know the answer to that myself. If anybody knows, if anybody can get the answer, drop it in the chat and educate us all. Great question. Sorry, I don't know the answer to it. So we have line 52, extracting the summary statistics, just a comment. And then on line 54, we're gonna add 1 more comment to print coefficient table. So one of the things you'll note is that for both outputs, for the plot and for the stats table, the last thing we're going to do is basically print something out. So for example, here I used a bare ggplot command. That is, I used ggplot and didn't assign it to any variable. And so because of that, it's going to immediately print. And we're going to do something similar with the stats table here as well. So there's a nice explanation about expressions in the chat, which should provide information about the curly braces. What I'd like to do is, because we're at the top of the hour, is we've been sitting here for about an hour now. Let's go ahead and take a break. So we will take a 10-minute break. Come back at 10 minutes after the hour. If you're in Arizona, that's 11:10 a.m. If you're elsewhere, it's 10 minutes after whatever hour you're in right now. So do that, and then we'll get this stats taken care of and get it into our plot. If you have additional questions, you can drop them in the chat window, and we can go from there. But take 10 minutes. I'd highly recommend that you don't sit in front of your computer. Get up, stretch, walk around, go check the mail. Go smell some fresh air, and we'll see you back in 10 minutes. Okay, folks, welcome back. We should probably get started in one more minute here. We can start working on some more stats. So before we start changing some things, I want to go back and address the question that Jessica asked. Kelsey provided a really nice explanation from R in the chat about why we have both parentheses and curly braces. So we can see this in our server section for the output, the two output declarations. In render plot, we see render plot has an opening parentheses as well as an opening curly brace. And then for the output stats table, the render table has an opening parentheses as well as an opening curly brace. So the idea behind the curly braces is what it does is curly braces forces R to think about the curly braces as a single thing, as one unit. Now, so render table is a function. And so when we pass information to render function, we have to pass a piece of information. And then if we want multiple bits of information, they have to be separated by a comma. So if I scroll on up, we can see that sort of standard function syntax in select input. So select input is the function, and we're passing it three pieces of information. We're passing it the input ID, and then a comma. We're passing it the label, and then a comma, and then we're passing it choices. That's how a function works, is that we have bits of information, and each piece of information is separated by a comma. If we don't have the comma, and we just use empty lines, all this stuff is going to get run together in R's mind as a single thing. And it's not going to recognize things correctly. So what we do with those curly braces is we tell R, this is a single thing. And what it does is it allows us to pass multiple lines of code. Now, the example we have with ggplot, this is a single line of code. So the curly braces may not have been absolutely necessary for render plot, but they will be for render table. And we'll see a little bit more about the importance of curly braces and passing information to functions in Shiny in a moment. But here we're going to get back to go to fill in the code necessary to do our stats. So the first thing we need to do is to create the linear model. So I'm going to go ahead and create a new object called model, and then assign it a value, the less than sign and the minus sign. We'll use the LM function. In R means linear model. I'm going to specify the formula as, so formula equals, we're going to say bill underscore depth. So we're using the bill depth, which is on the y-axis, and we're going to predict that from bill length, bill underscore length underscore mm. Now we can say data equals penguins, but we don't want to just say data equals penguins. So why not? Yeah, so Luke got it. Luke nailed it. The problem is that this will do the linear model for the entire data set. And it will create that for the entire data set, ignoring species. We only want to run this model on data corresponding to the species that we are looking at. So we need to do the same subsetting we've done up in our ggplot. And so I could type in this entire thing that I did up on line 42. Or, because I know line 42 works, I'm going to go ahead and select that data subset. So penguins, square brace, penguins, $ species equals input $ species, comma, square brace. I'm going to copy that and place that in the data specification for my linear model. Feel free to type it out if that's what you prefer, but you want data to equal penguins, square brace, penguins, $ species equals input $ species, comma, square brace. All the idiosyncrasies of our subsetting right here. So now we've created our linear model. So that's all set. And what we should do is go ahead and down on line 54, extract the summary statistics. And so what I can do is I can create a new object, model underscore summary, and then assign that the value, so less than minus sign. And I call summary on the model. The last thing we want to do is print the coefficients table. And so what we can do is we can run model underscore summary $ coefficients. Now, the model summary object, this variable that I created on line 55, it's going to be a list, and it's going to have something called coefficients in it. Now, I know that because I've run this thing a couple of times, but maybe you don't know that. And the question is, well, how do I actually like test this code without throwing it all the way at the Shiny app? And so one way to do it is to go ahead and test out the code just in your console. Now, because this is RStudio, you can run individual lines of code by holding down the control button and pressing enter, or holding down command enter. But that won't always work. And for example, if I try to run line 51, it should fail. And let's go ahead and try it. I'm going to hold down control. You can try this too if you like, control or command enter. And it's going to give me an error. It says error in, and some tibble garbage. It says object input not found. And that's because this input thing is coming from our UI section. And in here in the server, like, we didn't call server. As far as R knows right now, input doesn't exist. And so what we have to do is we have to be a little creative, and we have to go ahead and, if we want to test things out, what I will do is I will go ahead and copy this piece of code and drop it into my console, and then update it with the information. So in this case, input $ species doesn't exist, but I do know that double quotes Gen2 does exist. So what I'm doing is doing a hard subset of the data, so that we're only looking at the Gen2 penguins for this test of the linear model. Now I run that, no errors. So now at this point, I can head back to my script, my app.r or server.r, if that's what you're working with. I can run the model summary using the regular way of doing things in R and RStudio. So control enter will run the model summary. And now, and this is where I want to show you how RStudio can make your life a little easier. We can type in model underscore summary. And now when I type in a $, it recognizes that this model summary is a list and that it has a variety of things in it, one of which is coefficients table. If we want to print that out to the screen, we can put our cursor on that line, hold down control or command enter, and we've got all of our coefficient estimates, the standard things that we see in the output. We see the estimate as the first column, we see the standard error for that estimate, the t-value, and then the p-value, the probability that the estimate is significantly different from 0. Okay, so we've run our stats, and we have that plugged into our server section, but it's not going to show up in our app because we haven't told R to actually show it. Now we say, well, didn't we say to print the coefficients table? Well, when we do that, what actually happens is it is getting assigned to the stats table element of the output list. So we need to actually tell it explicitly to show that thing in our UI section. So we need to roll on up to UI. And this is a part of the UI that we haven't really done anything with. So starting on line 32, you see there's a main panel. So main panel is sort of where the good stuff's being displayed. These sidebar panels and side panels, that's usually where the user input goes. And the main panel is where you're showing the goods. So we have this thing, this plot output function, and it plots dist plot. So this is how we're actually seeing the plot that we created in our server section. So you say the function is plot output, and then dist plot. And note that this string, dist plot, matches exactly that element that we created in the server object, dist plot. So let's go ahead and let's do an update so that it's going to show our table. So one of the things that's nice about Shiny is that a lot of the stuff is pretty intuitively named. So we don't want a plot output, we want a table output. So I'm going to guess maybe there's a function. There it is, table output. This works sometimes it doesn't, but it is pretty intuitively named. So now we need to spit out the thing that's in output that corresponds to our table. I'm going to go ahead and look here, scroll on down. What did I call this thing? Output $stats table. So just to make sure I get it right, I'm going to highlight stats table, copy it, and then paste that string in here. Now note you want to go ahead and put that in double quotes. So this is important here. When we're referring to the parts of the output object, it has to be in double quotes. You don't want to try to do what I've done here, because R is going to look for something separate called stats table, and that's not what we want. So let's go ahead and wrap that in double quotes. Let's save this. Some of you might be noticing I've got an error, and that's intentional. So let's go ahead and let's run this to see if we can get our stats table to show up. And the answer is no, it does not show up. You're like, why not? And so we go ahead and scroll down and look at the error message. Here's our code. Here's the error message. And it says error in parse, blah, 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 unexpected signal. And what it does is it shows me line 33 has plot output, and then line 34 is table output. Yeah, that looks right. That looks like what I got. And then R uncharacteristically makes a helpful suggestion. And it says possible missing comma at, and it's close on line 34, and it points to the T, and it's close, but not quite right. And the real thing we need to do is we need to add a comma right after the plot output. Okay, so, and really this makes a lot of sense as far as our syntax goes, because there is a function called main panel, and we are passing things to main panel. The first argument we pass to main panel is this plot output. The second argument we pass is table output. So we're passing arguments and we're separating them by commas. Now this is important to note that because we're passing stuff to a function, they're separate things, they're separated by a comma. Now let's contrast this with our stats table creation down here. So render table is a function, right? So render table is a function. We got this open parentheses, but immediately we have now this curly brace. And what this curly brace allows us to do is type multiple lines of code, and R will treat it as a single argument. So all of this stuff from lines 51 to 59 is treated as a single argument. And that's because we added those curly braces. This is exactly what Kelsey said in the chat, is that this now R can recognize as a single thing, a single argument. If you have multiple arguments, then you will need to separate them by commas. And you could do that. You could have multiple curly brace things separated by commas. And I think that we may or may not see that later on. A quick question about double quotes versus single quotes. Single quotes would work just fine here. Just make sure that if you start with a double quote, you end with a double quote. If you start with a single quote, end with a single quote. I would recommend whichever one you choose, use it throughout your entire script for consistency's sake. Some folks just prefer single quotes. For these purposes, there's no differences between the two. Okay, so we have added this comma. Remember, that's what we were doing. We were adding the comma to get rid of that error. And try to debug that led down the curly brace rabbit hole. But let's go ahead and test our app. So make sure to save it with Control or Command S, and then press the Run App button. And what we should see is in the top left the same user interface for selecting a species. We have Adelaide selected by default, but I can select the chin strap, and we can see that both the plot and the coefficients table updates when we change species. But if I look at this table, it's like, okay, well, I've got estimates and standard errors and t-values, but I don't know what they're of. So one of these is the intercept, and one of these is my predictor, bill length. I can make an assumption that maybe the first line's the intercept, but let's be honest, we don't want folks to make those assumptions. We especially don't want our users to be asking questions about which numbers are which. Now, if we contrast this, I'm going to close my app. You don't need to close your app, but I'm going to go ahead and close mine. Let's contrast this with what we saw. I'm going to scroll up in my console. So if I look at what happens when I print out the coefficients, when I print it out, it's got a label for the intercept, and it's got a label for the bill length predictor. So why didn't it actually show up? And the question is, what are these things? So if I look at intercept and bill length, in R, these are not a column of data. So intercept and bill length are actually row names. Yeah, so the row names. And so that's the thing, is that it's not displaying, my app isn't displaying the row names. So, you know, at this point, we could try to look at the documentation, but let's just go for the quick and easy solution. So I'm going to open up a web browser, and the question is, how do I find this? So I'm going to say Shiny display row names. Maybe I'll get something good here. How to show row names in Shiny. So Stack Overflow, a pretty decent resource. Still some trolls on Stack Overflow, but it's gotten better. We can see the second hit is turn on row names in render data table. Maybe similar. I'm going to try this first one, how to show row names in R Shiny. Let's go ahead and look at this first hit. Whenever we look at the Stack Overflow, what we try to do is match a question or problem that folks had that is similar to us. So if I quickly glance at the problem, they have a data frame with row names, column names, that's fine. They've tried render table, and they've got blah, blah, blah to show a table. So we're going to scroll on down. And now we've got an answer. If you do not want to use the render data table or the other package, you can simply add row names equals true to render table. So the question is, did we use render table? Let's quick glance at R, scroll on down, and the answer is yes, we did use render table. to create that stats table. So here's render table. That's where we made all this junk. We did our linear model, extracted the summary stats, and then printed our coefficients. So I'm going to head back to the example. So they've got some indentation issues that they could fix, but if we have the relevant code starts here, they've got an output object and they're creating something called Tableau, and they use render table. And so render table, we see the first thing is, again, these curly braces, right? So we have these curly braces of render table where they're doing multiple things. So they have a data frame, they name the rows on the second line, and then they print the table. That's what they're doing when they say tab as vol, is they're just printing out the table. After the curly brace of render table, so this curly brace matches the first curly brace here, they have another argument, row names equals true. So they have comma row names equals true. So here's one, let's go ahead and give it a try. So let's go back to our app.r. We have render table. So the very first thing that we're going to pass render table is all of the code necessary to run the linear regression, extract the stats, and print the table. So those three things are part of basically one step. And it's viewing it as one step or one argument because we have those curly braces. And so after those curly braces, but still inside the parentheses for render table, we're going to say comma row names equals true, all caps. So we're seeing our syntax here where we have to separate different arguments by a comma. The first argument is all of this stuff. That's one argument. And the second argument is row names equals true. So we made one little change, and when we're doing the testing, we want to do small changes and then test. Small change and then test. So once you have that change, go ahead and save your file, and then when you're ready, save the file and press run app. And now what we have is the table, the same table that we saw before, but now it's actually showing the row names. So if you wanted to have a table that has row names you want to display, that's how you do it, is you pass the additional argument to render table to say row names equals true. And now when you select the different penguins, it's going to update the plot, and it's also going to update the stats. Because this is ggplot, we can do all sorts of fun things with this plot. We can change the names of the axes and change the size of the font and the different labels we use. We're not really going to do that because there's other resources for ggplot. So at this point, this is the extent of the app that I wanted to show to folks. We will, in just a moment, we'll take some questions. But one of the things I wanted to point out is that this is fine that we have an app that now I can run on my computer. I can send all of this stuff up to GitHub and have somebody clone the repository, and they could run the app on their computer too. But one of the things we like to do is we like to actually share these apps. And so the way we do that is probably the easiest way is to use a service called shinyapps.io. So I've headed over to a web browser. And what this does is shinyapps.io will actually host your code and allows you to publish your web app so that other folks can use it through their web browser. They don't have to clone anything from GitHub. You can just point them to a URL, point them to a web address, and your app will be available for use. So you can sign up for an account here. It's one of those things that it does actually require an account. The way I've done it is I've actually signed in through GitHub, which is very nice. So if you look at the Shiny apps, you can log in with GitHub. It's probably going to ask you some questions about permissions and authentication. If you don't have a GitHub account, they're free. It's easy to get. I'd recommend that you get one. And it should allow you to log in. So I've already done this once. And what's really nice is that once you've logged in, there's a pretty nice set of instructions for how to actually get your app up and running on the shinyapps.io. It requires one more additional package called RS Connect. So this is our Studio Connect package. And then you have to establish the keys to actually link your account to your computer, and then you can deploy your app. The drawback to shinyapps.io is that there is a limit to the number of computing time that you have per month. For a free account, you can always upgrade and have a paid account and get more compute time. And that might be something that you want to use if you're going to have a lot of people using your app. I will say that the University of Arizona is currently looking at a possible license with our studio to have basically a University of Arizona instance where you can deploy for free, apps for free to your through the U of A license. That's still ongoing though, so we don't have that finished yet. So hopefully that will be something that happens soon. So I would say take a look at Shiny Apps. I'm going to close my web browser here. Take a look at the shinyapps.io for more information about how to share with things and how to share your apps. And you know what I would say is that, like, if you want to do it, if you want to publish things, you know, don't wait for the U of A. Go ahead and give it a try, right? It doesn't cost you anything to have a free account. Get used to sort of sending stuff up and get things up on the web for other folks to use. I will say once more, if you want to do that, it really is fairly trivial. And I know that sometimes we can say it's trivial and really it's not. But if we look at the app that's open right now on my screen, there's a button in the top right that says publish. And really it's like opens up a dialogue for you to publish your account, publish your SHAP. And so it's actually going to ask if I want to go ahead and install packages. I'm not going to go through this just yet. I'm going to leave that to other folks. So it's going to install the PackRat, which is a package management package, and then that RS Connect for connecting to RStudio. I'm going to say no, but that's how you would do it. And it allows you to send up whatever latest changes you have to your server, to your app. I'm sorry. I will go ahead and say one more thing, which is the lesson that we just went through is available online. And all I got to do is find it. I will provide a link for that. And I'll drop it in the chat. So everything that we went over today is available at the URL that I'm going to drop in the chat here. So you can find what we did and from the very beginning. And I want to just stop here. So this is the material that I had planned for today. There's a lot you can do with Shiny App. In the link in the lesson that I provided in the chat, there are at the very end a bunch of resources that you can take a look at. There's because this is an RStudio project, naturally there is a nice cheat sheet. I think it's a 2-page cheat sheet that has a lot of the great functionality condensed and explained for Shiny Apps. There's a couple of tutorials for using Shiny that go into much further depth and a whole lot of the different functionalities than I went into here today. There's an interactive Shiny course actually linked in that resource page. More information on how to get to shinyapps.io. One of the things that you'll note is that the app that we did, like, it looked pretty boring. So that's the default theme for Shiny Apps. There are a lot of other things you can do with theming, a lot of different things you can do with colors and fonts and a variety of other things to make it look a little bit more aesthetically pleasing. And there's information in that lesson at the very end about how you can do various theming in Shiny apps. So at this point, I want to stop, and Austin has placed the cheat sheet in the chat if you want to take a look at that. But I'd like to stop and ask questions of folks. So are there things that maybe weren't clear? Other things you have questions about? You can either unmute yourself or drop your question in the chat.
Jack?
Yeah, go ahead.
I was wondering if, so you mentioned early on that you would open this up as a template and start working on it. I was wondering if there are also more complex examples of templates where there's, I've seen like I think whole web pages that are shiny with like different pages and navigation. And I don't know how to develop a website, but it'd be great if I could do it through R. So since I already know R.
Yeah, good point. So the first thing I'm going to do is not answer your question. I'm going to answer your question, but first I want to also highlight that we have a workshop on creating web pages with R using the blog down package. And I don't know if the person running that is still here. Nope. So the person running that workshop was here earlier. But what I would do is maybe if you can take a look at that workshop and see what they have to offer. But as far as other templates for Shiny, that's a good question. And I don't know right off the top of my head. I would do a Google search and head over to see what RStudio has to offer, to see what they have. It's actually pretty nice. They have a variety of different web apps, some of which are education related. There's a variety. These sorts of dashboards are pretty popular for public sector things. One of the things that we didn't do is we didn't do any of the tabs, and I'm just going to go ahead and check this COVID-19 tracker. You can see that there's a screenshot here. We're going to go ahead and head over to the app, and if we look, I'm going to jump back. We'll get back to this app in a sec here. This is the example. The really cool thing is that there's a link to GitHub. And this is not the exact thing that you were asking about, because they're not necessarily templates per se as so much as the one that we opened, but it does provide an example of how to do it. These are pretty slick apps where they have some nice visualizations. You can see that in the right-hand side, or I'm sorry, the left-hand side, this is the user input, just like we saw before, but they've got it sort of hovering over. We've got a different slider here. We can change the dates that are shown. We can move around. The other thing that's nice is that you can actually have separate tabs for separate types of visualizations. So that's what we've done here. So different sorts of region plots. And basically, these tabs allow you to have an entirely separate Shiny app in each of the different tabs. So that's what I would recommend doing, is heading over to, I Google search for Shiny templates, head over to the, where you can go right to the shiny.rstudio.com page, and they've got a whole gallery section. So that would be the place that I would go to first. Great question. That's one of the things that is both fun, is very exciting, is that there's a lot of cool things you can do in Shiny apps. There's a lot of ways you can spend a lot of time doing, making some fun things. There's and then, as folks probably seen in the chat, there's a contest for RStudio apps, and then tomorrow's session from 9 to 11 is that blog down session I was mentioned, which is how to how to create websites using R. And the HackMD site has additional links as well. So good question. Other questions about Shiny or what we did in our app? If you have general R questions about what we did, I'm more than happy to field those as well. Yeah, so there's a question about the R sessions. So so just in case folks aren't aware of those, every Tuesday morning we have R sessions. And the answer is yes, we will be doing them over the summer. I haven't established the schedule yet. I'll put a link to the schedule in the chat. That's what I'm looking at right now on my web browser. Summers are generally more drop-in sessions, a little bit lighter on the instruction, probably do maybe one lesson a month. And most of those are drop-in help sessions to get help with R and R Studio. The other thing I would mention is that if you have questions that are related to R and R Studio, and I'm going to go ahead and close these tabs, or try to, because they're chewing up a little browser memory, is that we can also go to, there is a Slack channel. Yes, another Slack channel where we do support for data science related questions. If you want to sign up for that Slack channel, I put a link in the chat. And the Slack channel there, we have a channel, R help, we have a channel Python help, I think a couple of other channels for HPC and help with Git too. But that's a spot where if you're not available Tuesday mornings, Mountain Standard Time from 9 to 11 a.m., you can ask your questions on the R help channel. And folks are usually pretty good about turning answers around pretty quick. And we really like questions in that Slack channel, because rarely a day goes by that I don't learn something about R from somebody else's answers. So and we're more than welcoming to lurkers. So if you just want to show up and read the answers and not post your questions, you're welcome to do that as well. So good questions. Oh, and it sounds like some folks are already on the U of A Data Science Slack channel, which is excellent. I will say that it's also a place, we have an opportunities channel. So if you are in the job market or thinking about going into the job market, the opportunities channel is where we post job opportunities that we hear about. So there are some cool things happening out there, a couple jobs in the opportunities channel right now. So one more reason to join in with that Slack as well. So I'll probably hang on the call for maybe 4 or 5 more minutes. Thanks to everybody for coming. If you have any questions, feel free to email me. I love the R questions. Sign up for the Slack channel and join the rest of the community, and enjoy the rest of your time at ResBazAZ. So thanks for coming, folks. Remember to fill out the feedback form. So before you leave, actually, maybe this would be a good opportunity to go ahead and click on that link that Patricia dropped in the chat channel, in the Zoom chat. And that is a feedback survey for the session, so the Shiny R session right now, to provide feedback on it. Again, like I said, we really do appreciate your feedback, and we revise and craft and update things based on your feedback. So take a minute, it's really short. We appreciate what you have to say. There'll be another feedback form after the entire Research Bazaar conference, asking for overall feedback. But that feedback form is just for this session right now. So please take a moment and fill that out before you go. And again, thanks for coming, folks. It's great to see everybody. You can also get the link at the bottom of the HackMD page as well.
Hi, Jeff. It looks
Hey, Austin.
there's aren't any more questions. So I'm just going to go ahead and stop the recording.
Sounds good, Austin.